Imagine you're flying at 35,000 feet above the earth. Outside the window, all you can see are endless clouds. Inside the cabin, passengers are sleeping, some are watching movies, others are enjoying their meal. Everything feels completely normal. Then suddenly, a loud warning sounds inside the cockpit. Within seconds, both jet engines lose power. The familiar engine roar disappears. The aircraft becomes strangely quiet. At that moment, a terrifying question comes to mind. Is the airplane about to fall from the sky? Most people believe that without engines, an aircraft cannot stay in the air. But the truth is far more surprising. Modern passenger airplanes are designed for situations exactly like this. Even if both engines stop completely, the aircraft does not immediately fall. Instead, it can continue flying for many kilometers, giving the pilots valuable time to react. This isn't just theory, it has happened in real life. And every successful landing has taught engineers something important. So, how can a plane keep flying without engines? What do pilots do during those critical minutes? And how does modern engineering help save hundreds of lives today? We're going inside the science of flight to discover what really happens when a passenger plane loses both engines. To understand what happens next, we first need to understand why an airplane can fly at all. Many people think an aircraft stays in the air only because of its engines, but that's not true. The engines do one important job. They push the airplane forward. The real lifting force comes from the wings as the aircraft moves through the air. Its specially designed wings create lift. That lift is strong enough to support hundreds of tons. This means something very important. Even if both engines stop, the wings do not stop working as long as the airplane still has speed. It can continue to glide through the air. Think of it like this. If you stop pedaling a bicycle, the bicycle doesn't stop instantly. It keeps rolling forward because it already has momentum. An airplane works in a similar way. At cruising altitude, it is already moving at around 850 kilometers per hour. That speed doesn't disappear in a second. Instead, the aircraft slowly trades altitude for distance. In simple words, it glides, and it can glide much farther than most people imagine. That's why the first reaction inside the cockpit is not panic, it's calculation. The pilots immediately begin working out how far the aircraft can safely travel and where the nearest suitable airport is, because every second and every kilometer now matters. The moment both engines fail, the cockpit becomes incredibly busy, but not chaotic. Every airline pilot trains for this situation long before carrying passengers. Within seconds, the pilots confirm what has happened. Then they try to restart the engines. If the failure was caused by heavy rain, volcanic ash, or a temporary fuel problem, an engine restart may still be possible. At the same time, the aircraft automatically switches to emergency power. Critical flight instruments, navigation systems, and radio communications continue working. This allows the pilots to stay in full control of the airplane. Next, they contact air traffic control. An emergency is declared. Nearby airports are identified. Weather conditions are checked. The runway with the best chance of a safe landing is selected. Meanwhile, the passengers may not even realize how serious the situation is. The aircraft is still flying smoothly. There is no sudden drop, no dramatic fall from the sky. Inside the cockpit, every action follows a carefully designed checklist, because in aviation, preparation is just as important as technology itself and those years of training. The difference between a disaster and a safe landing now comes. The most critical question: how far can a plane actually glide without any engine power? The answer is much farther than most people expect. A modern passenger aircraft can usually glide for about 15 to 20 kilometers. For every kilometer of altitude it loses, imagine an aircraft flying at around 35,000 feet. That's roughly 11 kilometers above the ground in ideal conditions. It may still travel more than 150 kilometers without either engine producing thrust. That gives pilots a real chance to reach a suitable airport or another safe landing area. But gliding doesn't mean the airplane is safe automatically. The pilots must maintain the correct speed. If the aircraft flies too slowly, it could stall. If it flies too fast, it loses altitude much more quickly. So every decision has to be precise, every kilometer matters. Every minute counts. This is why modern aircraft are designed not just to fly with engines, but also to glide efficiently. When the unexpected happens, that engineering has already saved hundreds of lives. In real-world emergencies, one of the best examples happened on January 15, 2009, just a few minutes after takeoff. US Airways Flight 1549 flew into a flock of birds. Within seconds, both engines lost power. The aircraft was flying over New York City. There wasn't enough altitude to return to the airport. Captain Chesley Sully Sullenberger had only a few minutes to make the biggest decision of his career. After quickly assessing the situation, he realized the safest option was not an airport, it was the Hudson River. Using the airplane's gliding ability and years of training, he guided the aircraft to a controlled water landing. The impact was powerful, but the airplane remained intact. Rescue boats arrived within minutes. All 155 people on board survived. The event became known as the Miracle on the Hudson. It wasn't luck alone, it was the result of excellent pilot training, smart aircraft engineering, and emergency procedures that had been practiced for years. This incredible landing proved to the world that even without both engines, a modern passenger aircraft can still be flown safely. When every second counts, so can a passenger plane survive? After losing both engines, the answer is yes, but only because modern aviation is built around safety. Every aircraft is designed with multiple backup systems. Every pilot trains for engine failure again and again, and every emergency procedure has been tested long before a real emergency happens. When both engines stop, the airplane doesn't simply fall, it becomes a glider. The wings continue producing lift. Pilots stay in control, and the aircraft still has a chance to reach a safe landing. Of course, every situation is different, weather, altitude, terrain, and the cause of the failure all affect the outcome, but one thing remains true: behind every safe landing are decades of engineering, thousands of hours of pilot training, and countless safety improvements learned from real events. The next time you hear the engines during takeoff, remember this: those engines are incredibly important. But they're not the only reason an airplane stays in the sky. If you enjoyed this documentary, don't forget to like, share, and subscribe to *RailForge***, because here we uncover the engineering secrets behind the world's most incredible machines. Thanks for watching, and we'll see you in the next documentary.